Hello, my name is Zane and I'm Candrone's GIS and Data Solutions Specialist. Today, we're going to take a deeper look at how researchers actually use the forest statistics we can extract from a LiDAR survey and how those statistics become predictive models. In another video, we pulled a forest inventory out of an aerial LiDAR point cloud, including tree count, tree heights, crown diameter, and other forest statistics. In this video, we will discuss how these data points can be utilized in research and how to filter or calculate the values you might need within your forest dataset. Before we dive in, let's do a bit of a refresher to find out how we got to the dataset you see here. After scanning a forest with a drone and LiDAR sensor payload, we calculated the ground class and normalized the point cloud. Doing this allows us to bring every tree to the same elevation for easier tree statistic extraction, similar to how a manual tree survey would act with a clinometer. After the forest has been normalized, we can then segment the entire point cloud, delineating and colorizing each tree individually. For a researcher, this is a great start, as we can now isolate individual trees, conduct our own measurements, grab snapshots, or clip the point cloud to be imported in another forestry software that might conduct further analysis on a per-tree basis. Going one step further, we can begin to filter for values that might be of interest to us, such as tree height and canopy area. Rather than requiring an individual to measure each tree and log them for tracking, we can simply run the filter within the software and extract the IDs, location, distribution, etc. of all the trees that fall within this filter. This is where the basic statistics lie, where we can look at total number of trees, our filtered selection, and draw simple conclusions like 15% of trees in our forested plot are greater than 20 meters in height and have a canopy diameter of at least 10 meters. These kinds of statistics are useful for many industries, and once this data is on your computer, it's just up to the researcher to ask the right questions. However, we can go even further. As you may be aware, just measuring a forest and receiving a table of these values is one thing, but doing predictive modeling is where the science gets really fun. A simple form of this is linear regression, where we assess correlation between two key variables. Let's say our hypothesis is that the taller a tree grows, its canopy grows as well. I know, how revolutionary. Whether you want to use your own statistical powerhouse software like R or MATLAB or a specific Python library, or you want to do it here in LiDAR 360, the main limitation is whether you have sufficient data to confirm your hypothesis. If we only had a small plot of 10 trees to run our calculations on, we wouldn't have much confidence in our conclusion. This is why aerial LiDAR scans are so useful, because we can capture vast areas at high point density, so that the only questions we have are, what else can we investigate, rather than spending time documenting all the limitations of our sample size. Now, it should be stated that research in forestry has progressed beyond the question of, are tall trees also wide? But if you have existing data, such as the population heat maps of maybe invasive species of beetles that affect tree growth, or forest fire distribution maps, you can incorporate these data sets with your forest statistics calculated here within LiDAR 360 to help understand if there is any correlation or potentially causation between your variables. Using further advanced models, and even utilizing AI, you can go a step further and begin running exploratory models that attempt to find connections that you may not have even considered. Using large forested data sets like these, made possible via aerial LiDAR, researchers can advance our scientific understanding of forests and the many key interactions that may impact their health. As always, we would like to thank you so much for watching and encourage you to check out our other videos.